All right, hey everybody. Today we're going to be doing section 1.5. I think I think you'll be just fine. But again, take all the notes because you're going to be turning in the notes as like your usual step one. Um, and whatever pace I go at, it's a video, right? On these, especially on these video days, you can pause the video, watch things again. Heck, I think you can even I'm positive you can. You can even like slow down a video or even like speed it up. But anyway, here we go. This is all about square roots. Let's get that mouse cursor out of there. So, what can I like? Maybe I'll say first, like, this first part can be thought of as really just review. I mean, just think about what we've talked about and the types of questions and problems we've solved already in Unit 1. Like, we've already been talking about some square roots and some squaring of numbers. So this is, some of this is just kind of like revisiting and things coming full circle. But if you were a little uncomfortable with square roots or squaring a number before this moment, don't feel too bad, because I guess now we are like officially covering it, and so you should be comfortable with it by the time we take like a test or something. So here we go, some notes. First of all, what does it mean to square a number? Again, you probably already know this. It means to multiply it by itself. For example, when you square 6, or 6 squared, you get 36, because that's 6 times itself. 6 times 6. You say it's 6 squared, and you can write it as that, like 6 to the second power, So that's squaring a number, is raising it to the second power. You probably already knew that. Taking a square root is like the opposite of squaring. And this is not like the math word opposite. In math, we got to be really careful. I should probably maybe come up with a different way to say this, because, the word opposite means something particular in math. But this is just like your regular sort of word opposite. And you'll see, because here's the thing. The square root of 36, written like this, is 6, because you're trying to figure out what number times itself is 36. The square root, okay? And then so the square root of 16, what number, when you multiply it by itself, would get you 16? So what's the square root of 16? You probably know that that's 4. Okay? And calculators can help out with this a lot if needed. Here's a question for you big brains out there. When you take a square root of a number, will the answer always be, nice? Like, what do I mean by nice? I mean something like this, like a nice whole number, or some, like a nice whole number, right? The square root of 16, that was just 4. That's nice. The square root of 36, that's just 6. That's nice. If you took the square root of 64, you would just get a nice 8, right? But of course, this answer is no. The answer is no. Just think about like the square root of 3 or the square root of 7. The square root of 3 is not a very nice answer. Okay? Like, it's not just some whole number. Because, like, think about it. What number times itself would be 3? Nothing nice, that's for sure. And again, like, it's tough not to mention things like square roots already in the class. Like, when we did section 1.1, we talked about, a little bit at least, irrational numbers, and how a lot of square roots are irrational because they have this crazy never-ending decimal that never repeats a pattern. So that's irrational because it's got like a never-ending, never repeating a pattern decimal, which is not nice at all. Like it's nowhere near a nice answer, like the square root of 16, or the square root of 36, or the square root of 25. But but we'll more on that in a minute. So here's some questions. Do you know this about square roots? Like what's true here? Can you say that the square root of 12 plus the square root of 4 actually equals the square root of 16? Is that true? Can you say that? Do square roots work that way? No, they do not. You cannot add square roots together. Likewise, you can't subtract square roots. You know what I mean? The square root of 16 minus the square root of 7, can you say that that equals the square root of 9? Do square roots work that way? No, that's false. But multiplying two square roots together, like the square root of 4 times the square root of 5, does that equal the square root of 20? Yes. And this one, yes. So square roots, the nature of square roots, they work this way. You can multiply them together. You can divide them together. They do work this way, but they do not work that way. So that's something worth remembering. Now take the square root of 32, for example. What is it? Okay. Like, what is the square root of 32? So let's kind of slow down for a second, at least a little bit, and actually talk about this specific example. Like, what is the square root of 32? Are you going to get a nice answer, or is it basically going to be like an irrational, never-ending decimal? Well, what are some nice square roots? What are some they're called like perfect squares, Like 36 is a perfect square. 25 is the perfect square directly below 36. Like in order, the perfect squares, I'm just going to write this down here because it's sort of a side note. But the perfect squares are like 1 is a perfect square because that's 1 squared. 2 squared is 4, so 4 is a perfect square. And then what's 3 squared? What's 4 squared? 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, and I'll just stop there. It's sort of a random place to stop, but so these are all like the perfect squares that if you took the square root of these, you'd get a nice answer. So this is going to be like a nasty answer, you know what I mean? Like an ugly answer. But check it out. Root 32 and 4 root 2. If you went on your calculator, okay, and again, like some of this is going to basically be all about, do you know how to use a calculator? Do you know what buttons to push to do like square roots or things like that? Now on a calculator like this, I see like right here the square root written like above this button. So this button is the squared button, but if I want to do a square root, I can do like this shift key. So I hit that key first, and so I do the square root of 32, and my calculator automatically does these parentheses, which is fine. So then I had to hit like right parenthesis. But that's what I get for like, that's an approximate answer for like the square root of 32. Now, 4 root 2, check it out. 4, and then I got to do like this second key on this calculator. Your calculator might be different. 4 root 2. I get the exact same answer. So anyway, here's what I'm kind of getting to, right? This and this are the same number. But this is what we call like a simplified version of that, The 5.65685424949, this would be like an approximation if we rounded this off to like 2 or 3 decimal places, it would be like an estimation, because we're just estimating it. We're like approximating it. But this would be like a simplified form of it. Let's do a bunch of examples and kind of give you the idea. Again, estimating square roots. Estimating square roots. Now this calculator, if you have one just like it, actually needs to be in classic mode. Like there's modes and there's settings to a lot of calculators. So if your calculator, if you type in the square root of 12 and it doesn't say that, then your calculator must need to be like in a different mode or a different setting or something. So when we're estimating, this is all we're doing. And I like personally estimating to like 3 places. So if I round this off to the 3rd decimal place, 464, because that 1, doesn't change the 4, kind of rounds down. If you remember about rounding, And then root 6, like what's root 6? You should start trying to do these on your own at this point because it's not really that complicated. Didn't even put in a right parenthesis, and that's okay on this calculator. So it looks like 2.449 would be like, and here's a symbol for approximation, like it's approximately equal to, I don't know if you ever saw this symbol before, approximately equal to that. And then, root 28, oops, I forgot if I did it or not. Root 28 would be 5.29, technically, if you want to round, like that 5 bumps the 1 up to 2, so 292. Really quick, people, pause the video and do these last 3 quick, okay? And then unpause. So make sure you pause the video in less than 5, 4, so you can try the rest of them, these 3. 3, 2, 1. Okay, here I go. So maybe you've unpaused at this point. And I'm getting for this 8.485, at least as an approximation. For the square root of 150, I'm getting 12.247. And the square root of 81, guess what? That's exactly 9. We don't even have to estimate that. The estimation is, it's an exact actual, it's 9. Okay, it's exactly 9. All right, now here we go. Now, I mean, I'm actually happy if the lesson so far has been like really, really easy. That's a good thing. I'm glad if the lesson so far has been like a piece of cake. Here, things might pick up a little bit. Business might pick up a little bit, as Jim Ross used to say on WWF. But here we go, man. Simplifying square roots. Okay? Here's how this is done. What you want to do is think about what you're trying to take the square root of. Now, is that nice? Is the square root of 12 going to be nice? No. But maybe I can break something off that I actually can take the square root of. So, can I break this up into like the square root of something times the square root of something? It would still be 12, but it's like I'm breaking it up because you can do that with square roots. Okay? But I need actually one of these square roots that I can actually do, like nicely. Now remember, the numbers that you can actually do nicely, I'll write again right here. 36 and then 49. I hope I'm not skipping any here. Whoa, 64. I knew I was. So 64, and then 81, and then 100, and then 121, and then 144, and then yada, yada, yada. So I actually tacked on 121 and then 144. So these are all the, I do not like the way that looks. So these are all the numbers that you actually can take the square. Now, it technically goes on forever, but I mean, like, these are the first most common handful of ones that you actually can take the square root of. So the square root of 12, and again, you got to be pretty good with your mental math here. The square root of 12 is the square root of 4 times the square root of 3. Now, this I can actually do. That's just 2. Now, the square root of 3 I can't do anything with. That's just going to have to remain the square root of 3. But at least I took the square root of something. Okay? Now this, what can I break it up into? You know, think about it, 75. And it's one of them has to be something you can actually do. All right, spoiler alert, 25. And by the way, you want to break off the largest perfect square you can. We'll see that here in a second with the next one. But the square root of 75 becomes this times, let's see, 25 times 3 again. So now this one just becomes 5. And unfortunately, you know, again, you can only do certain square rooting. Like, obviously, we're not going to be able to do, like, the entire thing because, look, the square root of 75 in the first place wasn't nice. So we're only going to be able to do, like, a square root of part of it. So this square root of 3 has to remain the square root of 3, even in, like, our final answer. Now, this next one, here, this one's a really noteworthy example, okay? The square root of 48, you know, you want to break that up. Okay? You obviously can break off a 4, but the really important rule of thumb is you want to break off the largest perfect square you can find. Okay? Which in this case is 16. So the square root of 16 times the square root of 3. So the final answer would be 4 root 3. Okay, now that is just one method. Like, this method follows, like, this property very religiously. You know what I mean? The fact that you can, like, multiply square roots together and you can divide them together, but you cannot, like, this kind of summarizes, like, some properties of square roots. But there's, like, a trick you might have learned from, like, me or another teacher in the past. So here's another way to do this. You just start breaking this down all the way. Right? So you make this little, like, factoring tree and you break it down to, like, its prime factors. Because, you know, 6 and 2... and you can't break down the 2 anymore. Not really. You know, you could say it's 2 times 1, but that doesn't really count. So 2, and then the 6 gets broken down again. So once you get it broken down to, like, all the prime factors, now what you do, again, this is like another method, it's kind of a trick. You find pairs. So I have a pair of 2's here. So that means a 2 is going to come out of the square root, and any singles, any loners, like this 3 is not a pair with anything, it's just like a 3, like a single 3. Any singles stay underneath the square root. Okay? So here with 75, I could say it's like, you know, I could start off with 25 and 3, but I mean, like, what, 5 times 14, is it? No. 5 times 15. Okay? So 5 times 15, again, having a calculator, would it be handy and helpful? So 5 is done, but the 15, right? So once you've broken it down all the way, you look for pairs. I have a pair of 5s, so that comes out, and then a single 3 stays under there. Again, so you're getting the same answer we did before, which is supposed to happen. Again, you don't need to do it both ways. You know, I'm giving you 2 different methods to sort of choose from. So over here, 48, you know, again, I could start with 16 and 3, but why don't we just do something a little different? I think 4 and 12. So that 4 can get broken down again, 2 and 2. 12 can get broken down into 3 and what, 4? So the 3 is done, but this 4 can get broken down. So wow. So watch this now. I have one pair of 2s, so I bring a 2 out. But then I have another pair of 2s. So these 2s and then these 2s. So another 2 comes out of the square root. And this 3, single, stays under there. So out here, yeah, you're going to have to like actually multiply this together. 2 times 2 is 4. And if there was like multiple single numbers, like let's say there was like a single 7 as well as a single 3, it would be like 3 times 7. And you'd have to multiply the numbers that remained underneath the square root. Anyway, at this time, pause the video, because in about 5 seconds, I want you to try these 3 on your own. So pause the video and then unpause after you've completed these last 3. So you got 5, 4, 3, 2, 1. Okay. So now hopefully you've unpaused. And the way I would do this one is we have a perfect square of 9, which I can just do. So that final answer is 3 root 2. This one, 72. 9. But 9 is not the biggest one, actually. So I'm not going to do the square root of 9 times the square root of 8, because the biggest one, I think, is 36. Okay? So again, you got to find the biggest perfect square you can. So that's just 6. And there we go. Ooh, the square root of 192? Man. See, I'm not above grabbing a calculator. 192 divided by 4? Okay, so 4 is going to work, but I have a feeling there's something bigger. Okay, 16. But I think there's something bigger, because guess what? If it was like 16 times 12, there's another perfect square in 12, so I feel like 16 is not the biggest one. So 192 divided by, I don't know, 36? No. See, that didn't work out. What else is there? 64? How about 64? Bingo! So we got the square root of 64 times the square root of 3. And so this just becomes 8. But the other method, let's do the other method in case you liked that method. So check it out. Breaking it down. Hey, we could stick with 9 and 2 again, or you could do 6. It doesn't matter, because you're going to break it down all the way anyway. So this becomes that, and so here we go. Pair of 3s. And there we go, same final answer. 72, heck, let's see what happens. You know, we got like 9 times 8. It doesn't matter how you start breaking it down. You're going to get the same numbers in the end anyway. So that's 3 times 3. Those are done. This becomes 2 and 4. That's done. But this 4 becomes... So here we go. We have all of these. Let's see here. Check it out. We have a pair of 3s and a pair of 2s. So we have a 3 that comes out, a 2 that comes out, and this 2 is a single, so it stays under there. So this becomes a 6, and again, 6 root 2 is our final answer. If you did 192 this way, heck, I don't think I'd blame you too much. Let's see, what's 192 divided by 2? 96. So technically this is like 2 times 96. So that's done. But 96 can get broken down again, right? Into like 2 times 48. So that 2's done. Now 48 is like 2 times 24. I don't want to keep doing this. Let's do with the 2's. That's weak sauce. So 24 is 6 times 4. So 6 gets broken down again. Again, you just kind of break it down all the way. And so look at all these numbers I have now. So here we go. We have a pair of 2s right there. We have another pair of 2s. Another 2 comes out. Now check it out. We have another pair of 2s. And I think one single 3 right here. So 2 times 2 times 2 is 8 root 3. So again, we'll follow up on this a lot, but simplifying square roots, there's 2 different methods. I like the blue method, but you got to be able to find like the largest perfect square you can right off the bat. With the red method, it doesn't matter how you break it down because you're going to like break it down all the way USA anyway, and then do the whole like pairs and singles thing. Anyway, let me know if you have any questions on the homework assignment, but be ready to turn in the notes and the homework as usual.